Hello and welcome back to my channel. And from today onwards, I'm going to start a new series which is known as Numpy. So Numpy is a Python library. It is a Python library to perform the mathematical operations on the arrays. So when you talk about the mathematical operations on the arrays, then it's all suitable for the machine learning things. You can use it for the other purposes as well. It's not hard and fast rule that you will only use it for the machine learning, but yes, it is very much useful for the machine learning things. So in case of machine learning, if you read about the NumPy, then why you read the NumPy for the machine learning for the array operations? You know that the two-dimensional arrays, they are represented as the matrix. And in case of machine learning, many mathematical operations around the matrices will be needed. For example, suppose you have a matrix, and in that matrix in every column you put some color, right? You put some value, you give some value to some color, and you are trying to recognize a flower whose petals are green and whose petals are red and the stem is green and the leaves are green, which is something like a rose, right? So you can give different values to these colors. You can give some value to rose, you can give some value to the green color, you can give some value to any other color, whatever you want to use, right? So usually two colors will be fine. So when you see a flower which is a rose, then you can plot those colors on a matrix. In different rows and columns you can put different colors. For the area where the red color will be needed, you can put all those values which are corresponding to the red color in those cells of the matrix, in those rows and columns of the matrix. And wherever you think that there can be represented a leaf, so in those row and columns you can put the value corresponding to the green color, right? And whenever some new flower comes up to your model, to your machine learning model, and you ask him whether it's a rose or not, then in that case what you can do, you can simply compare the two matrices, the one matrix that you have created for the flower that has come to you, and the second matrix is the model which you have created, and you have a model already in place that these are the kind of the characteristics which corresponds to a flower which is known as the rose. So you will compare both of them, you will compare both of the matrices, and if both of the matrices are similar to a large extent, then you say that it seems to be a flower which is rose. So this is one of the examples, right, where you can understand that where it will be needed, the matrix operations will be needed for the comparison and all that. So this is one example, and the other example is that you can consider is somewhere if you want to create a software, we want to create a model which can recognize the handwritten things, like if you write handwritten, counting from 1 to 9, 0, all those things. If you want to compare, like whosoever has written manually on a paper, like I have written 2 or I have written 1, and if I want to find out whether it's 1, 2, or what is the digit which is there, then in that case we can already create a model where number of situations can be created, number of things can be placed already with the model, so that it can recognize what number or what digit has been entered or has been written by the user, right? So to do this, what you can do, you can create a number of situations. Suppose for digit 2, you can create different situations. Some people write like 2 something like this, a horizontal line for the 2, but some people write like they move it like this. So you can do you can make your machine learning model understand that what are the different situations where these values can be where values could come, what kind of thing could come to you for a particular digit. So you can create 2 or 3 two or three things for your model with the help of which it can recognize a particular digit which has been handwritten by someone else. So it does nothing. It simply just convert that digit into that kind of matrix that you already have with your model. One matrix will be with your machine learning model, and the second matrix you will create for the input that you have received, and you will create the matrix of the same size, like the number of rows and columns, and then you will plot the values in different cells, different rows and columns makes a cell, right? So you can put the values in the different cells. Suppose someone is writing like 2, so wherever this 2 will come up, whatever cells it will cover, you can put that value as 1. Okay, you can put that value as 1, and rest of the things you can leave 0, right? So that way you can understand that yes, this if whatever a user has written, if I plot a matrix and then I try to compare it, then it will be it will be compared, and if it matches and it resembles a lot, like around 70 to 80%, then in that case we can say that yes, this handwritten amount or this handwritten digit is 2 or 3 or whatever. So there are a lot of use of matrices in machine learning. So in machine learning, if you have a basic idea about the machine learning, you make the machine learn, right? You tell him that it will recognize any digit like this. Something like when you were a child and your parents used to teach you that how you will identify a particular number, a particular digit. Then in that case you used to learn those things from your parents. Your parents used to teach you that yes, this is 2, this is 1, this is 3, this is 4. So that way those things are inside your mind, and whenever something comes up in front of you, you are the best machine. I mean, humans are the best machine. You don't need to learn that way. You don't all the matrices and all those operations are inherently provided to you. So but to create a machine, create a software which can provide you which can assist you to find out whether a particular thing is a flower, or whether a particular thing is a specific digit, or whether a particular thing is a face of a human. So all those things can be done through the matrix operation. So now you must have understood why we needed this library. So this library is very much rich into manipulating the values, writing the values, plotting the graph, and comparing the values, splitting the arrays, splitting and slicing the arrays. So all those basic mathematical operations on a matrix that will be needed as part of your machine learning projects, all those things are can be done by this Python library, which is known as the Numpy. So in a nutshell, Numpy is a kind of library which is which provides you the set of functions using which you can simply perform the array manipulation operations. You can manipulate the arrays, 2-dimensional arrays, 1-dimensional arrays, wherever you need it, right? So this is one thing, right? So the second thing is that in Python you might have studied about the lists. So if you have studied about the lists, you can see that the list can also be similar kind of thing as array. So why we cannot use the list? The second thing, or the second topic of today's of this particular video, is why we cannot use the list. Why to use a new concept which is known as the array. So there is a difference between the list and array. List is a linked list, right? So if you remember from your college days, where you must have studied about the C language, if you have studied about the linked list, then in that case you must be aware that linked list is a kind of arrangement where the data is managed at the different memory locations. Some memory location is, suppose it's 1000, and some can be other like 3452. So these two memory locations are different locations, and they containing two different values, and we create a link between these two. The first value and the second value, first memory area and the second memory area, we create a link. To create a link, another prime pointer you used to create. That pointer used to have the address of that second node in the memory, right? Address of that second node in the memory. So if you do that, then in that case you are having the need of more memory. right? And also the data is not, contiguous, right? In a contiguous memory location, it's not continuously placed in the memory. You have to every time use to this particular pointer to reach out to the another memory area. So this is another overhead in using the Python lists. So that is why these libraries like NumPy, this has been written. Apart from NumPy, there are other libraries related to the machine learning which helps you to work on the machine learning things. So those libraries are known as the scikit-learn and panda libraries as well. So you can use those libraries. We will understand those libraries as well. So first target is the NumPy library we have to understand. So basically, in case of arrays, you get the contiguous memory location. In the contiguous memory location, you don't have to use this particular thing like I have to reach out to the internally. It reaches out to the other node through the linked list operation, which is an overhead. So you don't know if you use the list and array, you won't be able to differentiate that behind the scene what is happening. But yeah, in case of arrays, compared to lists, the things are easier, the things are more efficient, the memory uses is efficient because there is no need to store a pointer which is pointing to the next memory area, which is in the memory and containing a different value. So these are the things that those are really important when you start the NumPy. So basic things we have understood. In the next video you will see that first of all how we can, or what editor we can use to practice our NumPy library. So I will use the Jupyter notebook. So I will show you that how to install and how to launch it and how to use it in the next video. Till then, have a nice day and bye bye.